Hello, students. We're doing the last section in topic 4. We're talking about congruence in overlapping triangles. So what do we see here? I forgot to delete that. Yes, I see overlapping triangles and I see right triangles. Sometimes when they're overlapping, it's a little bit more difficult to see them. So one strategy for overlapping triangles problems is to unoverlap them. So I'm going to pull all the information with it and pull all of the points, but I'm going to make them not overlap anymore. That can sometimes help us see the parts that line up a little bit better. If you really want, if it gets flipped in your mind, you can even reflect this one so that you would not only separate them, but then flip one over so that they're oriented the same direction. What else do we see in this picture? I see right triangles. Do you think there's a way to prove these triangles are congruent? Maybe. We're not doing a proof, but it's always kind of good to think what we have here. When the triangles overlap like this, they're giving us a freebie. Okay, we already have an angle and we already have a side. Is there another thing that these two triangles have in common? Yeah, it's this place right here where they overlap. So from B to C, which would be right here, is the same as from, oops, did I do that wrong? BC is the same as from B to C. I did not do it wrong. BC, it's messing with my mind a little bit. BDC, BDC. Okay, so what's that called? How do we know that side BC is the same as side BC? Yeah, that's the reflexive property. You guys are getting used to that one. That's good. Reflexive property of congruence. Okay, and then now we have a list. You should have a list in your mind of the different ways that we've talked about proving two triangles are congruent. We started with side angle side, and then we added to that side side side, and there's 5 of them that you're supposed to know now. We have angle side angle. We have angle angle side. If you can find those pairs on 2 sets of triangles, you can use those as a reason why the triangles are congruent. The special one is hypotenuse leg. And that only works for right triangles. But just because it's a right triangle doesn't mean it's hypotenuse leg. So of these 5 reasons, we could use hypotenuse leg, but we don't know the hypotenuse, so it's not going to be that one. Which of these 4 is it? Well, what do we have marked? We have a side, we have this beautiful looking right angle, and we have another side. So what's that called? Good. So I could say, I'm not doing a proof, but if I was, if I'm just engaging with this figure, like what's everything I can find out about this picture? I would say triangle ABC is the same size and shape as triangle DCB because of side angle side. Okay. Is there anything else I could say about this figure? Anything else I see? I see true triangles. I see they're congruent by side angle side. I see that they overlap at BC. One other thing that I did not do a super good job explaining to you guys is after you show that a pair of triangles are congruent, you can pick off other information. So we already know that these sides are the same and these sides are the same and these angles are the same. What else do I know? If the triangles are congruent, I also know that side AC is the same as side DB. That's not because I was given any information on that. It is because now that I know the triangles are congruent, all their parts are congruent. So because the triangles are congruent, now I know that's congruent. What else do I know matches up? I know angle A matches up with angle D. They're in corresponding parts. They're in the corresponding location. And I also know that angle C on this one matches up with angle B on this one. Okay, so all three of these, the reason I know that is because corresponding parts of congruent triangles are congruent. You guys remember the shortcut way to write that your book uses? Corresponding parts of congruent triangles are congruent. You might see that on SAT written that way. That means if you have two congruent triangles, then all the parts that you weren't given are also congruent. And if I was asking you to do a proof, which I didn't, but if I asked you to prove that angle A was congruent to angle D, you would show the triangles are congruent, and then you would end your proof with this. And your last reason would be corresponding parts of congruent triangles are congruent. Okay, we're going to do one proof together. And I'm going to set it up, but then I'm going to stop and I'm going to stare at it for a while because there is a lot going on in this figure. I type it out. So what do we see? See here. I see overlapping triangles. I see some angles that have the same marks. I'm going to make this a lot simpler in our proof and call this angle 1 and angle 2. Okay, and it's given to me that angle 1 is congruent to angle 2. Do we see any other angles with the same marks? Okay. Yep. This one and this one. So I see angle 3 is congruent to angle 4 that was given in the markings. And what else do you see? You see the overlapping triangles? Oh, good. I could also put little numbers for this. Should we call this 5 and 6? Why not? What do you guys know about angle 5 and angle 6? Good. Okay, they're congruent because of vertical angles. Vertical angle, they're vertical angles, and we know that vertical angles are congruent. Good. Okay. What am I trying to prove? I'm trying to prove that line segment VW is the same as line segment ZY. But I don't have any markings for any of the sides. And that's not good because there's no angle, angle, angle theorem. So I need at least one side. Where do you guys think we can get a side from? Good. This side is congruent to itself. Okay. So I'm going to do this stuff I add to the figure in blue, maybe. So I could say that line segment VZ is congruent to line segment ZV. Okay, I may or may not need that, but that's definitely true here. What else can we do? Let's we have vertical angles. We're trying to get to VW and ZY. And there's a bunch of different ways to do this problem. I'm going to start by focusing on this triangle. This yellow one right here. Do you guys see it? This is just the way my brain is seeing this problem. And there are other ways to do this problem. That was 1 and 2. What kind of triangle is that yellow triangle? Anyone know? Well, these two angles are the same. So what kind of triangle is it? Nice. All right, that's pretty much the key to this proof, is noticing that this triangle in here is isosceles. It's isosceles not because it has marks on it. It's isosceles because these base angles are congruent. And to be really good at proofs, you have this bunch of knowledge, all this stuff we learned from before. You have to put that somewhere in your brain or in a notebook or in your textbook, and you have to go grab that stuff and put it into your proof. So I learned something in the past about isosceles triangles, and now I'm reaching back to that information and I'm going to use that to prove my case, to win my argument about why these two things have to be the same. Okay. So I think that's okay. If I have that, then I'll be allowed to say that these two are the same if this triangle is isosceles. And if those two are the same, do I have enough to prove any triangles are congruent in here? I don't know. Let me start the proof, and then, we can back up and start over again. I'm going to start with that where I was going, which was that angle 1. I'm going to start by catching up and getting these two segments congruent. So I'm going to do angle 1 is congruent to angle 2. Okay, that was marked, that was given. And then I'm gonna do that triangle. Triangle, what's it called? VXZ is isosceles. And how do we know it's isosceles? What have we learned about before that tells us if we have a picture like that, then the triangle is isosceles? Well, it's actually the converse of the isosceles triangle theorem. It says that if base angles are congruent, then the sides opposite them are congruent, then you have an isosceles triangle. Okay. Next, there's different ways to do this. Because, yeah, let's go get that side. I might change the order here, but I think we'll just roll with it the way it is. No, I am going to change the order. Okay, so we have an isosceles triangle. Now I'm going to go get angle 3 and angle 4. So angle 3 is congruent to angle 4. Okay, that was also given to me in the markings. Okay, and now I'm going to go grab the sides. So line segment VX is congruent to line segment ZX. And the reason for that is the definition of isosceles triangle. Okay, so I told you it's an isosceles triangle. So these are the sides there's two sides that are the same on an isosceles triangle. Okay, now I'm going to use this piece of information. So now I'm going to look at these pairs of triangles. Now there are other ways to do this problem, but right now I'm going to do it this way. And I'm going to say this little triangle is the same size and shape as this little triangle. Am I allowed to do that? What do we have marked on those two triangles? We have a pair of angles that match up. I just showed you a pair of sides that match up. What else do we need? We have side, angle, side, 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 angle, side, angle. angle, angle side, or hypotenuse leg? I'm going to use angle side angle. Okay, because I know angle 5 is congruent to angle 6 because vertical angles are congruent. Okay. Now I've showed you those two little green triangles. They're congruent. Triangle little one, VWX, is congruent to triangle ZYX. And how do I know? Well, I just showed you. I showed you they have a pair of angles, a pair of sides, and I just showed you that these little two angles, these are little curves, are congruent. Okay. And that is angle, side, angle, triangle theorem. All right, I'm almost done. I want VW to be congruent to ZY. Are they? Well, the two little green triangles are congruent. So that means, you know, angle 5 and 6 are congruent. This side and this side are congruent. Angle 3 and 4 are congruent. That means angle W and angle Y are congruent. It also means all their parts are. So the last step, if you've proven triangles are congruent, then you can just pull off the corresponding parts. So you can also notice it's the first two letters and the first two letters. That is called corresponding parts of congruent triangles are congruent. That's it. It's long. It's challenging. It's really good for your brain to be able to think deductively. It's one of the hardest things for your brain to do. So hang in there, study it, keep thinking, be good, work hard, keep learning.